Hey everyone, this is Mike. Today we're going to take a look at parabolas. So, parabola is the curve from a quadratic or x squared. So for a parabola, again, it's quadratic functions, which is something with x squared or a squared function. And the basic shape of a parabola would pass through 0, 0, go through 1, 1, go through 2, 4, and then 3, 9, which is off the scale. Go through negative 1, 1, go through negative 2, 4, and then negative 3, 9, which is again off the scale. So, a quick thing about parabolas here is that if I take the slope from 0, 0, slope from 0, 0 to, let's say, 1, 1, that's 1 minus 0 over 1 minus 0. That slope, that average rate of change is 1. If I go from, let's say, 2, 4 to 3, 9, then that's 9 minus 4 over 3 minus 2, which is 5. So the rate of change increases as x increases. So we could say the slope increases, it's a little up arrow there, increases as x increases. And that's true for the negatives as well. As x decreases below a certain point, it decreases as well, or the slope would decrease as well. Now this parabola right here, x squared, if you can kind of see how I should have drawn it, is that it was mirrored about this line right here, and this line right here is the axis of symmetry, and that would be the axis of symmetry. That's the line about which everything else is mirrored. What about the equations for these things? Well, your standard form of a parabola would be f of x is equal to x minus h squared. Hey, x minus h, just like the circles, plus k. And this standard form is also, again, sometimes called hk form. A general form would be something like, call it g of x is equal to ax squared plus bx plus c, which is our general form for a quadratic equation. And important to all parabolas is the vertex. And the vertex is right here, the point where it changes from decreasing to increasing. And that happens at the vertex. In standard form, h and k give the vertex. It's at h comma k. And again, it's where it changes from decreasing to increasing, or vice versa. It's where it turns. And this would be our local, I'm going to use extrema, because we could have a parabola that's upside down. Notice that this parabola is said to hold water or open up. The ends of the parabola are pointing upward, not downward. It goes from decreasing to increasing. That opens upwards. Okay, let's take a look at some specifics. This parabola right here looks a bit like the standard parabola in terms of slope, but it's moved from the vertex at 0, 0 over to 1, 2 right here, and then up 1, 2, 3, right here. So it goes right 2, up 3 to get to that new vertex. It still opens upward. So what's h? 2, and what's k? 3. So f of x, in this case, the equation would be x minus h, quantity squared, plus k. This would be x minus 2, quantity squared, plus 3. That would be the equation for this vertex, or the equation for this parabola based on where the vertex is. Here's another one. And we've got two interesting points marked out right here. This is when x equals 0, y is equal to negative 2. This parabola has a y-intercept at negative 2. And its vertex right here, let's see here, the vertex is to the left 1 and down 1. So h is to the left 1, so negative 1. K is down 1, so negative 1. So f of x, it looks like x minus a negative 1 squared plus a negative 1. So I guess we'll just write this as x plus 1 quantity squared minus 1. Okay. But there's one big problem here. Take a look. This opens downward. It goes from increasing to decreasing. It's flipped upside down. And if you remember our section on transformations, we flip something upside down by putting a negative sign in front of it. We're going to do that here too. Does this need to be negative? How could we check? I think if we take a look at f of 0, we'll get negative 0 plus 1 squared minus 1. That's negative 1 minus 1, right? Because this is negative 0 plus 1 squared is negative 1 squared is negative 1. So minus 1, that's negative 2. So f of 0 is negative 2. F of 0 is negative 2. Cool. That checks out. This is just as it should be. If it was plus 1, if we negated both terms, that wouldn't work. So this is what we want. Negative the quantity x plus 1 squared minus 1. Excellent. So if I have an equation like this, f of x is equal to x plus 2, quantity squared, minus 7, I can find the coordinates of the vertex by looking first. Let's start over. Let's start this over. So I can find the coordinates of the in 3, 2, 1. I can find the coordinates of the vertex just by reading them off of the equation for the parabola. F of x is equal to x plus 2 quantity squared minus 7. And this 2 and 7 are important because remember it's x minus h quantity squared plus k. So in this case, h is equal to a negative 2 and k is equal to a negative 7. So the coordinates of this vertex are negative 2, negative 7. If I have a parabola that's in standard form, sketching it's pretty easy. The vertex is at 1, positive 3. So I go over to 1, 3, and I find that. That's going to be my vertex. And then I can put some points in, like I could say g of 0 is equal to 0 minus 1 squared plus 3. G of 0 is equal to, let's see here, 1 plus 3, 4. And I'm going to guess that g of 2 is 2 minus 1 squared plus 3. Hey, look at that. G of 2 is also 4. I'm going to guess that if I take negative 1, I'll get negative 1 minus 1 squared plus 3. So that's negative 2 squared, or 4 plus 3 is 7. So g of negative 1 is 7, which would be somewhere up here, call it. And the same thing for g of 3. See, when I found this vertex right here, what I actually found was the line about which this entire parabola is symmetric. I found the axis of symmetry. It lies on the vertex. If I find the vertex, I found the axis of symmetry. Now, what about actually sketching this thing? A little bit harder because it's hard to draw parabolas properly. They get really steep, really quick, a lot quicker than I think people think. But we found it by doing our standard method of finding something important, like the vertex, and then plotting out points. What about something that's not in standard form? Well, again, I want to try to complete the square. So we'll take x squared minus 6x is x squared plus 2 times negative 3x. That negative 3 squared is 9. So what I need is x squared plus 2 times negative 3 x plus negative 3 squared, and then 9 plus something, right? This 9 has to be 9 plus something, call it k, has to be equal to 5, so k is negative 4. X minus 3, quantity squared, minus 4. Great. Otherwise, I'm just going to put points into here. 3, negative 4. Otherwise, I can just put points in here, and it's going to follow the same 1, 2, 3. It's going to follow the same general increasing pattern as the other ones that we've found and drawn. 1, 2, 3, 4 to negative 1. So let's go ahead and let's draw this. And again, you can see just how steep it starts to get. Starts off very flat at the bottom, and then it just quickly gets very steep very quick. So it goes from flat to very steep to steeper still to even just incredibly steep just a few units out. That's a terrible drawing, but I think the idea is kind of clear. Where's that point and where's this point? If I wanted to find them, I'd say 0 is equal to x squared minus 6x plus 5. 0 is equal to x minus 1, x minus 5, right? So 0 is equal to, let's see here, x is equal to 1 or 5. Those are the roots or the solutions or the x-intercepts for this parabola. So it should be there at 5 and it should be here at 1. So I missed when I was drawing it, so maybe we should be checking here, but f of 4 is equal to 16 minus 24 plus 5 is equal to negative 3. Okay, so that checks out. And f of 2 is equal to 4 minus 12 plus 5, which is negative 3. So that checks out. I just missed with these. Again, it gets really steep really fast. There we go, that's better. So we always check points. And I think we just learned that right here. Check some points. We don't want to make a mistake. We need to check some points. And we can do that by finding the roots is helpful. We can find the intercept over here. That's helpful. And we can just put some random points in. That's helpful. How would we find this right here, the intercept where that should be? That would be f of 0, which is 0 minus 0 plus 5. So that's all the way up here at plus 5. That's another good point to check right away. Seems like maybe I didn't do so great on this one, and I should have checked some points. Let's take a parabola. F of x is equal to 2x squared minus 20x minus 5. And we're going to determine, without graphing, whether the function has a minimum or a maximum. If it has a maximum, it opens downward. If it has a minimum, then it's going to open upward. And I can determine that by looking right here at the leading order term. Leading order term is 2x squared, and that 2 is greater than 0. Therefore, this thing opens up, and it has a maximum, or a minimum. Maximum has a minimum. Now we need to find the minimum value and determine where it occurs. The minimum value occurs on the vertex. The vertex occurs on the axis of symmetry. And the axis of symmetry has the x-coordinate minus b over 2a when it's written in this general form. So for this parabola, this value would be minus b, so that's minus a negative 20 divided by 2 times a. That's 2 times 2. 20 over 4, or 5. And f of 5 is equal to 2 times 5 squared minus 20 times 5 minus 5. So that's 50 minus 30, or 20. So, find the minimum and maximum and determine where it occurs. It occurs at 520. Identify the function's domain and its range. Well, the domain is going to be all real numbers. And the range, it's got a minimum of 20. Does it have a maximum? No, because it opens upwards. So its range is from 20 to infinity. All right. I want to end with 2 word problems here. For the first, we have a ball thrown upward and outward, so like that, from a height of 88 feet. Oops, not 88. From a height of 8 feet. The height of the ball in feet can be modeled by f of x is equal to negative 0.1 x squared plus 0.7x plus 8, where x is the ball's horizontal distance in feet from where it was thrown. And our first question is to find the maximum height of this ball and how far from where it was thrown does the maximum height occur. Do we know that it's going to be a maximum? Yeah. Negative 0.1 x squared. Negative 0.1 is less than 0. It's got a maximum. It's going to go and be that kind of downward opening parabola. So for the max, what we're going to do is we're going to find, again, x is equal to negative b over 2a. So that's negative 0.7 over 2 times negative 0.1. So that's 0.7 over 0.2, or 7 over 2, 3.5 feet. Cool. And then we've got to figure out f of 3.5. Now, the problem with that is that I'm not really into doing all that calculations. I am, however, into having my calculator do all those calculations. So what I'm going to do is I'm going to put this into my calculator. I'm going to take 3.5. I'm going to store it as x. And then I can do negative 0.1 x squared plus 0.7 x plus 8 and get a value and get, what is this, 9.2 feet? And I'll have this equation saved for later in case I need it. Okay. Let's take a look at the next part here. The next part wants to know how far does the ball travel horizontally before hitting the ground. To find that out, I think what I want to do is I want to go ahead and say when it hits the ground, h is going to be equal to 0. So I'm looking for f of x to be equal to 0. And instead of solving all of this, you know what I'm going to do? I'm going to use the quadratic formula. Rather than try to brute force my way through this or factor or something, I'm going to use the quadratic formula. Okay, all over 2 times negative 0.1. The quadratic formula, again, being x is equal to minus b plus or minus the square root of the quantity b squared minus 4ac, all of that divided by 2a, which for these particular values gives us this. And again, I'm going to take my calculator and have my calculator figure that all out. So, I'm going to start with the numerator. That's negative 0.7 plus square root 0.7 squared minus 4 times a negative 0.1 times 8. Close the square root, close the numerator. Divide it by the denominator. 2 times negative 0.1. Close the denominator. Enter. We get negative 6.1. Not what I want. I'm looking for a horizontal distance. So I need this to be greater than 0. Rather than input that all again, I'm going to hit second. I'm going to hit entry. I'm going to arrow my way over here and change that plus to a minus. It's the negative case in this quadratic formula that's going to give me the answer that I want. Enter. 13.1 feet. Great. So in this case, x is equal to 13.1 feet, and we know that the height is going to be 0. So how far does it travel? 13.1 feet. Then it hits the ground. So one last part of this. Asks us to graph the function that models the ball's parabolic path. Let's do that on our graphing calculator. So we're going to again take it and let's go y equals, and I'll clear those. What is it? Negative 0.1 x squared plus 0.7 x plus 8. I'm going to do a little zoom. You know what? Zoom fit. Because I don't know how big this is. So we'll just ask it to zoom fit. Ah, cool. We want to capture more of it. So zoom. Oh, let's go to window, not zoom. We don't need it to be too negative, so we'll make this a -1. Let's have our x go to 20. And then we'll graph that. There we go. That's cool. Ah, so there we go. There's our function. It does something like that. Let's take, we'll just draw a nice little set of axes here. It starts off right here. It's going to go up. It's going to flatten out. It's going to hit its maximum. It's going to come back down. It's going to come back down, get steeper, and it's going to strike the ground. So let's just draw that. Where does it start at? Right here. It starts at a height of 8 feet. Where was its maximum height? We found that it was 3.5 feet out at a height of 9.2 feet. So this is 3.5, 9.2. And then where did it hit the ground? We found that it hit the ground at 13.1 feet out. So that's what our graph looks like. And we've got 3 important points labeled. Great. One last problem to look at. This is a nice standard problem here. It says Farmer Ed has 750 meters of fencing. And he wants to enclose a rectangular plot that borders on a river. If Farmer Ed does not fence the side along the river, find the length and width of the plot that will maximize the area. So, the standard thing, and there's a drawing in the book that illustrates this, is you call this width x. And then your length here is going to be 750 meters of fencing minus these two widths, 750 minus 2x. So what's the area? Is length times width is negative 2x squared plus 750x. And we're looking for the maximum, which means we need to find what point of this graph? The vertex, which means we're going to do x is equal to minus b over 2a, so we can do this without even getting calculus involved. So this is negative 750 divided by negative 4. Calculator, come help me. 750 divided by 4, 187.5. Oops. So this should be 187.5 by 187.5. And this length right here, calculator, times 2 minus 750, 375. Great, and we're going to take that and we're going to multiply it by 187.5. And I'm playing a little loose with the signs, but I know that this should be positive because I should have subtracted this differently. 70,312.5 square feet. That's the maximum area that can be enclosed. Okay, that's a lot, but I hope it helps you out and you do well with this section. I will see you in the other videos for some more problem solving.